Hello, welcome to a video on solving systems of equations by elimination. Elimination works best when both equations are in standard form. Ax plus by equals c, which means x and y are on the same side. Here are the steps. 1. Multiply if necessary to get one of the variables to have opposite coefficients. Step 2. Add the two equations together to eliminate one variable. Step 3. Solve the resulting equation. Step 4. Substitute the value found in step 3 into either of the original equations. Step 5. Solve for the remaining variable and write your answer as an ordered pair. All right, let's use those steps and get started. Example 1. Both equations are in standard form. We will notice that we have a positive x and a negative y. So we will add the two equations together. Y is eliminated. Divide both sides by 2. Now let's substitute 4 into one of the original equations to solve for y. I'm going to substitute it in the second equation. And I can add y to both sides, so y is equal to -4. Be sure to write your answer as an ordered pair. You can always check it by substituting in 4 for x and -4 for y into the equations and make sure they are true. Example number 2, you'll notice that the y's both have a 1 for a coefficient, but they are not opposite. So we can multiply one of the equations by -1. I'm going to choose to multiply the first equation by -1. And now I have a negative y and a positive y, so I can add the two equations and y will be eliminated. Divide both sides by -6. X is equal to -2. Now let's substitute in -2 for x in either of the original equations. I'm going to substitute it in the first equation. Add 4 to both sides, and y is equal to 0. So our answer is the ordered pair, -2, 0. Example 3. We need our coefficients to be opposite. So one way to do this is to multiply the second equation by a -4, because then we'd have a positive 8x in the first equation and a negative 8x in the second equation. And I can add those equations to eliminate x. So I multiply each term in the second equation by -4. I can add the two equations together. X is eliminated. Divide both sides by -10. Now substitute y equals 3 in one of the original equations. I'm going to choose the second one just because it has smaller numbers. And subtract 12 from both sides. And divide both sides by 2. So we know that x is equal to 2 and y is equal to 3. In example 4, You can eliminate x or you can eliminate y. It just depends on what you want to multiply by. I'm going to multiply the first equation by 3. And I'm going to multiply the second equation by 5. So that I'm going to eliminate y. Multiply each term by 3. The second equation, I'm going to multiply each term by 5. And then I will add the two equations together. Y is eliminated. Divide both sides by 5. X is equal to -1. Now I'm going to substitute in -1 in one of the two original equations. I'm going to choose the second one. Again, it doesn't matter which one you pick because these are two lines. They will intersect at the same point. Subtract 2 from each side. Y is equal to 1. Write your answer as an ordered pair. -1, 1. Example 5. I'm going to choose to multiply the first equation by 2. That way I can eliminate x. Well, look what happens here. When we add the two equations together, we have 0 because we have 0x and 0y. So 0 is equal to 20. Not sure on what planet that is true, but not here. So 0 does not equal 20. This is false. So when our variable is eliminated and what is left is false, we conclude there is no solution. Which means if there is no solution, the lines are parallel. In example 6, I'm going to choose to multiply the second equation by 3. Well, look what happens here. When we add the two equations together, we have 0 equals 0. This is a true statement. The variable has been eliminated, and what is left is true. So in this case, we have infinite many solutions. Which means if we graphed it, the two lines would be the same line. Another way to write this is you can write the sign for infinity. So we can say infinite many solutions. All right, and in this video, we have one application problem. However, there are application problems in another video. Solve the application problem using a system of equations. A total of 10 rooms at a hotel are rented at rates of $110 per night and $150 per night. The total amount of money collected for the 10 rooms is 1,340. How many rooms were rented at each rate? Let X represent the number of rooms at $110, and it tells us to let Y represent the number of rooms at $150. So one equation is going to be for the total rooms rented. Well, the total rooms rented were 10. So X plus Y is equal to 10. And then our second equation is going to deal with money. So we have 110 times the number of rooms at that price plus $150 times the number of rooms at that rate. That's going to equal our total money. And then from here, you can use substitution or elimination to solve. It's up to you. But the answer would be that we have 4 rooms at $110, and that means we have to have 6 rooms at $150. That's it for now. Be sure to watch the next video where we have lots of application problems set up. Bye for now.